Hey everyone, welcome to Unit 5. In this video we're going to focus on patterns and expressions. So let's look what we got here. So Logan built this pattern. How many tiles will he need for position 5? So if we look at the data we're given here, we see position 1 we have 3 tiles. Position 2 looks like we have another 3 on top of the other 3, so we've got a total of 6. And as you can see in the third one, it's increasing another 3. So in position 1, it's 3, 2 is 6, and 3 is 9. So we want to look for a pattern on what's happening here. And as we can see, it's increasing by 3. Now, in math, we can use something called a variable. In this case, I'll choose the letter n. N is just a fancy, variable is just a fancy name we use in math that means letter, and this letter can represent something. Okay, usually it represents a number missing in an equation or an expression. In this case, I am making n represent the number of tiles. Okay, now if I want to solve something further down the line, if I asked you, what would be the number of tiles in position 10? You could draw it out, keep on adding 3 each time, but a quicker way is to come up with an expression that will apply to any position that you want it to. Um, so when I'm looking at this, I see that if I multiply 3 and 3, because there's 3 in each one, by my position number, it gives me how many tiles there are in total. For example, n 3 times position 2 would give me 6. 3 times position 3 would give me 9. 3 times position 1 would give me 3. So I can come up with an expression here of 3n. And if there's no symbol in between these, this is assumed to be multiplication, okay? So 3 multiplied by n. Just as a side note, when we have a number attached to a letter like this number is referred to as the coefficient, okay? So I can apply this expression and find out how many tiles I can get in any position. For example, if I ask you how many tiles would be in position 10, I just plug in 10 for n, and I would say 10 times 3, that gives me 30 tiles in that position. Okay, let's look at another quick example here. In position 1 here, I have 1, 2, 3, 4, 5. Okay, 5 tiles, I'll just call them again. And position 2, I see I double that again. I've got another 5. Position 3, it increases by 5 again. So again, I can come up with an expression, and I can say, uh, sorry, there's not 5 tiles, there's 6 tiles. I miscounted. So I can come up with an expression of 6n. So 6 of these tiles multiplied by the position number, okay? Actually, n would represent the position number. That's a mistake in this PowerPoint. Um, so 6 times 10 would give me 60 in position 10. Okay? So this is just called an expression right here. So there's some terminology surrounding numerical expressions. So if we were to add something like the numerical expression 5 plus 3, we could also say the sum, okay? The sum is 8. Okay, so the sum of 5 and 3 is 8. For subtraction, you guys probably heard all this before. A difference means subtraction, the product means multiplication, and the quotient means division. I don't want to spend too much time on that. Okay, so again, we can use different phrases and terms to mean the same thing. If I were to add 3 and 7, I could say I'm adding 3 and 7. I could say the sum of 3 and 7. I could say 3 increased by 7, or I could say the total of 3 and 7. Okay? Um, if I were to say 3 more than 7, that would be 7 plus 3. Okay? So it's just different ways of expressing the numerical terminology here. And that, of course, applies to subtraction. You've probably heard, if the temperature decreased today, it means the temperature went down, or what's the difference between something. between the temperature in the morning and the evening, and you'd subtract to find that answer. Okay, so there is different terminology that you need to be aware of in order to help you out with your expressions. Okay. So the difference, this is just some extra practice here. The difference of 8 and 1, okay, that means the same as 8 subtract 1, which will give you 7. Or the product of 12 and 6. This means 12 multiplied by 6. And multiplication can be represented by a dot as well, for those that didn't know. The sum of 5 and 9 just means addition, and the quotient of 12 and 3 just means that you're dividing. Okay. So let's do some more practice here with our expressions. What does this mean when I say 10 minus x? Well, it means the difference of 10 and x. Or you could just say 10 subtract a number. Number 2 could mean 6m, okay? That means multiply because there's no operation indicated there. When it's attached, a number attached to a letter like that, it's assumed to be multiplication. So I could say 6 multiplied by a number m. Or I could phrase it as the product of 6 and m. Number 3, I could say 12 divided by a number y. I could plug a number in for that, or I could say the quotient of 12 and y. And number 4, I could say a number k, a number which I can throw in here for k, add 7 to it, and I call it the sum of k and 7. So, if you were going to write a variable expression for the following, how would you do it? Well, you just kind of think about it. It's, your age 5 years ago. So you could represent your age by a variable and then take away 5. Okay, so in this case, I just chose x and minus 5. For example, I'm 33 years old. So if I want to know my age 5 years ago, I plug in 33 for x, subtract 5, and I get 28. Twice your age, well, again, I would just take my age and multiply it by 2. So I can choose a letter. In this case, again, I chose x and multiplied it by 2. Or my age in 8 years, how old am I going to be in 8? I would say a variable. I could say x, and my age in 8 years would be plus 8 years. X plus 8. Okay, so again, more practice here. So these are multi-step ones. So 5 plus x minus a number. Okay, so 5 plus x minus 3. Sorry. So 3 times y less than 4. So I would say 3y subtract means less, and then 4. So 3y minus 4. 8 multiplied by y minus 7. So I would say 8y subtract 7. Okay, product of 10 and m, so that means just 10m. Decrease means subtract 7. So 10m minus 7. Okay, and so on and so on. Last page here. Define a variable to represent the unknown and write the phrase as a variable expression. So 10 miles per hour faster than the Honda. So you can let x, or any letter you want, sorry, equal the speed of the Honda. So the speed of the Honda, and I'm going 10 miles an hour faster, well, that's just going to be x plus 10. 7 inches shorter than Jill's brother. Okay, we could make a variable equals Jill's brother's height. And then if we're 7 inches shorter, it's going to be the brother's height minus 7, right? So let b equal the height of Jill's brother, and b subtract 7. 5 acres larger than twice the size of my lot. Okay, so this is an example in where we have to kind of read it backwards, work our way backwards, okay? Because if we let k equal the size of my lot, we need to add 5 on at the end, okay? So we're going to multiply the size of my lot times by 2, because twice, and then we're going to add 5. Okay, so this would actually be written not with the 5 first because it's first in the equation. It's actually going to be written last. We're going to write it as 2k plus 5. So 2 times your lot size plus 5. And last one, $7.50 times the number of people plus a $20 group registration. So again, we're just going to say, oh, sorry, I can't get this on the screen here. Let's try and move. No, not working. So we would just say 7.5 times y, which is the number of people, okay, plus the $20 on top of it. Okay, so it will be, can't really see it on the screen there, but 7.5 y plus 20. Okay, and that's it for this week, guys. Good luck in your quiz, and come see me if you need extra help.